Alright, let's have a quick look at the featurescape V24 preview. So this is a prototype developed to test our ability to traverse very quickly very large featurescapes. And as indicated in the proposal, these are 28.5 million objects, 48 features per object, and a 49th feature is added with a uniformly random value to enable the random sampling of this feature space. So what we'll do now is just go very quickly through the actions that generate the sorts of images and visualizations you see in the proposal. So let's click on the link. So what we have here is the 38 patients, 38 images, link to CA microscope, link to CBio. So to learn more about the patient, one could go to CBio and find out more, all the way down to the tissue images. And then a random seed that keeps changing in the interface. And this random seed is what guarantees that every time we sample the landscape, we get a random set of objects. It's really at the core of our ability to use MongoDB as the data layer for client-side multivariate statistics visualizations. So just like in Snapshot, let's pick FSD1 and FSD2. They're not too far from each other. So what we have here is the features already sorted by an unweighted pair group average clustering algorithm. That's why we see similar features coming together. You can also see at the end how a nearest neighbor clustering algorithm would represent these variables. You can also, of course, move the threshold for clustering and find out where these similarities are and how they are related to each other. Okay, back to the visualization described in the snapshot. So FSD1 is here, FSD2, so it's this one here. And you get the same representation you saw before. So this is with 1000 objects. Those of you familiar with MongoDB will recognize the find object URL encoded here, including the image case ID represented here. So this is really a straightforward use of MongoDB as an indexed backend. So you'll notice that this image is slightly less well defined than the ones in the snapshots, and this just reflects the fact that the snapshots were created with 2000 features or 2000 objects, and we are just using 1000 here. So we are resampling, this time 2000 objects, and we're going to be using the same two parameters. There they are again all together. FSD1 is here, matching with FSD2. So we're looking at this one here. And there we are, FSD1 and FSD2, and now a better defined image. Okay, and in the interest of completeness, let's do it now with, say, 5000 objects. I'm going to pick another image. By the way, if you try to put more, you get a little warning that after 10,000, you run into performance issues. Basically, you'll have to wait a while for the results. So let's sample this one. And after 8 seconds, we got the results. So again, FSD1. So we do expect a much better defined image now. There it is, right here. FSD1, FSD2. It's processing a much larger number of features. So what we get here is the non-parametric distribution of values. And again, you see the much better defined ridge for this particular image. Okay, so the same way that the quantiles are stretched along the axis, the color scheme represents a value between 0 and 1 for the fraction of the distribution that falls into a given column or row. So the sum of intensities across one row or one column would be exactly equal to 1. And as a sanity check, if you look at the identity diagonal, we get exactly this relationship. So all of the objects within this row and within this column fall exactly within this range of quantiles between 0.05, looking down here, so 0.05 and 0.10.